In this video, we are going to find the minimum value of the function f of x equals x squared minus 2x minus 3, all divided by 2x squared plus 2x plus 1. Before we move on, don't forget to give a like, subscribe to our channel, and turn on post notifications. For this particular function, there is actually a way that does not require calculus to find the minimum value of this function. So I'm going to let y equals to this rational function. Then I'm going to put 2x squared plus 2x plus 1 to the left. So we have two x squared y plus 2xy plus y equals x squared minus 2x minus 3. Then I'll regroup the terms according to degree of x. And which gives 2y minus 1 all multiplied by x squared plus 2y plus 2 all multiplied by x plus y plus 3 equals 0. So we kind of have a quadratic equation about x, as you can see, if you treat the expressions on y as coefficients. Now notice that because the denominator of the rational function 2x squared plus 2x plus 1 can be rewritten as 2 times x squared plus x plus a half, which can be further written as x plus 1/2 all squared plus a quarter, which gives 2 times that perfect squared plus 1/2. So we can see that it can never be equal to 0, because the minimum value of just the denominator would be the term after the perfect squared, and that is 1/2. So I can say it's always at least 1/2 and hence larger than 0. And the reason that I do this is that from this we can say that all inputs of x will give a valid output for y, because there is no value for which this rational function would be undefined. As in, this function can only be undefined when the denominator is equal to 0, but it can never happen. So that means for the quadratic equation that I've set up just now, all input of x are valid. So that means for any values of x, this quadratic equation should have real solutions. So from this I can say that the discriminant of this quadratic equation is non-negative. Now we know that the so-called discriminant is actually an expression of y. So let's see what we will get. By definition, we have 2y plus 2 all squared minus 4 times y plus 3 times 2y minus 1. And it seems it's a quadratic. So expanding and simplifying, we have minus 4y squared minus 12y plus 16, which we can divide both sides by minus 4. Of course, the sign larger than or equal to has to be swapped into less than or equal to, because we're dividing both sides by a negative number. From this we know that y must be between minus 4 and 1. So from this we can say that any value of y that is outside this range between minus 4 and 1, say for example if y is minus 5 outside this range, then the quadratic equation above over here cannot give real solutions. So now the candidate for the minimum value of this function will be the lower bound of this range, which is -4. So let's see whether -4 is attainable. Let's check. If y equals -4, that means we need to solve x squared minus 2x minus 3, all divided by 2x squared plus 2x plus 1. Then I'll move the bottom part to the right and rearrange the terms to one side, and we have exactly 3x plus 1 all squared. So indeed we can find the real solution. Indeed it's a repeated root. That means we know that when x equals -1/3, we can attain the minimum value of this function, and that is -4. So we can conclude that the required minimum is -4. So this is the final answer. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.